In this video, we're going to talk about how to perform operations like addition, subtraction, and multiplication with vectors geometrically. So I first want to begin by talking about how we multiply a vector and a scalar. So let's look at an example. So geometrically means I want to do this visually with the picture. So let's say that I have a vector and it's pointing in this direction, and I'm going to call this vector v and use my notation for vectors where I put an arrow on top of it, and that's why I know it's a vector, not just a scalar. Okay, so now let me draw 2v. So if you multiply a vector by 2, what that's going to do is it's going to give me a vector in the same direction, but twice as long. Okay, so if I were to draw something like that, same direction, twice as long, that might be something like this. Okay, so that is 2v. So let's do another example. What about if I multiply by a negative number, like negative, in fact, what about a negative fraction, like negative 1/3? Negative 1/3 v. Okay, so the fact that we multiplied by a negative number will mean it's in the opposite direction. So the negative means it's in the opposite direction. And the fact that I'm multiplying by what number? By 1/3, if I ignore the negative, means it's 1/3 as long. So it's 1/3 as long. Okay, so if I were to draw that, it needs to point in the exact opposite direction, but be about 1/3 as long, so maybe something like that. In fact, let me try to draw it a little bit straighter. So a little bit straighter, hopefully. Okay, and pointing this way. So opposite direction, that's what the negative does. And then the 1/3 means it's 1/3 as long. Okay, and then what if I multiplied by 0? If I multiply by 0, it means I'm multiplying the length by 0. And that means the length is going to be 0. And if the length is 0, it means I just have a dot. And the dot is called the 0 vector. And the 0 vector has no direction. Okay, so 0 times v is a vector still, but it's the 0 vector. And the 0 vector has no direction. All right, so now let's talk about how we add two vectors. Okay, so how do we add two vectors now? All right, so I'm going to draw a picture. So in my picture, let's have a vector u, and maybe u is going to go horizontally like this. And then I'll have a vector v that I'm going to add to it. So let's just make u and v. Let's put this in a different color. Let's make them both just sort of originate from the same point here. So their tails are both lying in the same point, but of course they don't have to. Because we've seen that with a vector, it doesn't matter how we sort of move it around, as long as I keep the length the same and pointing in the same direction, it's the same vector. Okay, so this is how we add two vectors. What we do is, if I want to do something like u plus v, what I can do is I'll take v and I want to move it so that its tail, which is here, lies on the head of u, where its pointy end is. So if I do that, this is what v would look like. I'm drawing it in gray here so I can sort of distinguish it from what it looked like originally, but it's the same vector. So what we're doing here is we are putting this head to tail. So I'm putting the head of u sort of on top of where the tail of v is. Or I can think about it the other way. I'm putting the tail of v where the head of u is. Okay, and when we do that, if I were to sort of draw a line here at the top, it makes this parallelogram shape. In fact, that line at the top, if I were to put an arrow there, that's the same thing as the vector u. So that is actually the vector u as well. So now the sum of u and v is the vector that begins at this corner where you started, and it ends at the tip, at the head of v. So that vector right there is u plus v. Okay, so that the sum of the two vectors lies on this diagonal of the parallelogram. So one key thing that I want to note about this picture is that note that if I add two vectors in this order, u plus v, so that's sort of where I went along the u direction first, this way, and then up along the v direction. That's the same thing if I had traversed the parallelogram in the other way. So if I had gone up the v direction first, and then the u direction this way. So it's the same thing as v plus u. Okay. So the technical way to say that is that vector addition commutes, or it's commutative. The order in which we add the vectors doesn't matter. Okay, so visually, the sum of two vectors satisfies what is called the parallelogram law. The parallelogram law shown above. And that's basically what we did here in this picture, constructing this parallelogram by lining up these vectors head to tail and then drawing that diagonal. That's the parallelogram law. All right, so finally, let's talk about how we subtract two vectors. So now let's subtract two vectors. Okay, so I'm going to draw actually the same vectors. I'll draw u and v again. So I'll draw my vector u, and okay, I'll put an arrow on it so it's a vector. I'll draw my vector v. So here is the vector v. But now let's say I want to compute v minus u. So I want to subtract two vectors. Okay, so the way we do that, the way I subtract two vectors is I take v and I will actually add the vector negative u to it. So when I write negative u, I mean negative 1 times u. So negative u is a vector that is in the exact opposite direction that u is in, and it's going to have the exact same length, because ignoring the negative, I'm multiplying by 1. So that's where negative u points. And now I need to add negative u to v. So now I make my parallelogram. Okay, so I'll do the head to tail thing, and I'll put negative u here. And then I'll fill out my parallelogram. So I can fill out my parallelogram by drawing on this other side. Okay, and now I got to draw that diagonal of the parallelogram. Okay, so I'm adding v plus negative u. So I'm going to start at this corner point, and I'm going to draw the diagonal to the opposite corner of this parallelogram, and that is v plus negative u, or v minus u. That's the vector that I wanted. Okay, so I'm going to put this in a bubble here. So note that when I subtract two vectors, what I'm actually doing is I'm adding negative u to v. And we just add those two vectors now by doing the parallelogram law that we saw above. All right, so returning to our goals, I forgot to do this at the end of the last video, but at the end of the last video, we had finished defining and giving examples of what vectors were. In this video, we talked about how we do things like addition and subtraction of vectors geometrically. In the next video, we'll introduce some more vector notations to start writing vectors with some numbers, and then define the magnitude and the direction of a vector.